Okay, what I'm going to demonstrate here is how to pluck out some numerical data summaries from complex data sets. And I'm not saying this data set's overly complex, but it does require numerical data to be extracted from jumbled categorical variables. So what we've got is the Melbourne maximum temperature, mean maximum temperature for every month from May 1855 through to 2013. So this is for the weather station on the corner of Latrobe Street and Victoria Road in Melbourne. So it's one of the oldest weather stations in Victoria and one of the oldest in Australia. So what we've got is 3 columns of variables, or data, 3 columns of data and 3 variables. We have 2 categorical variables in column A and B. We have the year and in column A, and in column B we have the month of that year. And then in column C we have the only numerical variable, which is the mean maximum temperature for that month. So the question is, for example, how would we find the average or mean maximum temperature for every May since 1855? So all recorded Mays, months of May. How do we get the average temperature for that, and then how do we get the standard deviation for that as well? So we'll do it for 2 months. We'll do May and we'll do June. And so I'm just putting together a little summary table here, which I use just to organise myself in a spreadsheet. And let's do so mean and SD for standard deviation. Well, maybe I'll use the Excel term for it, stdev, standard deviation. So one way we could get the average is to go equals average, that we know, and then select all the months of May. Here the months are listed numerically, so May would be 5, month 5, and go through, scroll down, find the next 5, so on and so forth, until we've got all 149 of them. That's one way of doing it, but that's extremely laborious and not recommended. So what we do instead is we use the average if statement. And all the statements and functions that I talk about in this little demonstration are all in the self-guided Excel tutorial on the subject homepage under topic 2. So we can go average if. So we're asking Excel to do the hard work for us and go, we want to get the average of a certain numerical variable based on a parameter in another column. So I'm going to ask Excel to go average if a value in column B. So I click on the top B to select the whole column, or I could have dragged the mouse down across all the months all the way to the bottom, but just to do it quickly I just click on column B, comma, equals 5 for the 5th month. And see how I put it in quotation marks? We'll also see some variance on the way that we can do this, but we'll do it this way to start. Comma, column C. So we're asking Excel, please find the average of values that correspond to there being a 5 in column B, and average the value that's found in column C. Press enter and there we go. Straight away Excel has given us the average temperature, maximum temperature in May across all years that records have been taken. Now we can do the same very quickly for June or month 6, average if, column B. Now we could go quotation mark equals 6 quotation mark. And I do it that way first because using that method you can type in words. It'll actually search for the word, not just numbers. Or we can do it quickly. We can just click on a cell which has the value that we're looking for. So here B3 has the value 6. So let's click on that. Column C, bang. So June, the mean maximum temperature in June over the last 149 years is 14 degrees Celsius, or just a little bit over. So about 1.65 degrees cooler than May, as we'd expect. So that all works nicely, the old average if statement, fantastic. But what about if we have to do the standard deviation? There's no such thing as that, as if we go equals standard deviation if, no such thing. So we need to find another way. And there's a method for it. And it's called subtotaling. And again, I'm going to go through the subtotal quite quickly here, but the full explanation with screenshots is in the self-guided lesson. So first of all, I'm going to select the entire worksheet by clicking that top left button. Then I'm going to click on filter, and that allows us to filter out certain data or hide particular cells that don't contain data that we're not interested in. So these are the little menu, drop down menu buttons come up in each column. It's fantastic. Thank you very much, Excel, for making it so easy. Currently they're all selected, so I'm just going to select on the month of May 5 and go OK. And look at that. Now it's hidden, it hasn't deleted, it's just hidden the rows which don't correspond to a 5 in column B. So that's wonderful. So now one might think, oh, we can just go stdev and highlight all these and we're going to get the standard deviation. Well, no. As you can see, a normal array comes up. It ignores the fact that some of the rows are hidden and still selects them. So it doesn't just go for the visible rows, it also selects the hidden rows. So we have to use a slightly different function, and that's called the subtotal function. It's a fantastic one. And subtotal allows us to do certain Excel functions, for example, average, counts, max, min, standard deviation, based on data that we can see or data which is hidden. In this case, we only want to get the standard deviation on data that is hidden, that we can see, and we do that by using these codes down here. So subtotal is one of these weird Excel functions where you've got to type in a code, you can just type in the words. So we're going to use code 107 for standard deviation. Standard deviation S means standard deviation on the sample. Standard deviation P means standard deviation on the population. So that's the standard deviation of the true mean. We don't have the standard deviation of the true mean here. Well, technically we do because we have all recordings that have ever been taken, but we don't, since records began, but we don't have every May ever. So we're going to use the standard deviation of the sample. And as you'll see in topic 3, the only difference between the standard deviation of the population and the standard deviation of the sample is the equation for the standard deviation of the sample you divide by n minus 1. For the standard deviation of the population you divide by n. So if you selected standard deviation P there for the population standard deviation, you'll be underestimating the standard deviation. So we'll play conservative and go the standard deviation of the sample formula. That was probably too much information for now, but there you go, for full disclosure. So we go subtotal, code 107, which means standard deviation, for only cells that we can see. And I'm going to scroll down, I'm going to select all these cells. There we go, and I'm going to press enter. And look at that, I've gone column B instead of column C. We want to get the standard deviation of column C. Obviously the standard deviation of column B will be 0 because it's got all the same numbers in column B. So we'll go column C. Well done, Alistair. So the standard deviation is 1.05. So I'm just going to type that over here, 1.05. Just going to round it to the 2 decimal figures. And then I'm going to remove the filter and see what happens. The subtotal is automatically changed because now all of a sudden those rows are visible again. So we can do 2 things. We can manually enter the standard deviation into there that we've recorded separately over here. Type it in there for posterity. Or we can use a slightly clunkier way of doing it. Just one extra step. One alternate way, I should say. So we filtered for the month of May. Now I'm going to select all those cells, and this is a workaround. It's not the super scientist way of doing it by any stretch of the imagination. Now I'm going to post those numbers over there, and there they all are. And now I'm just going to go back to the normal standard deviation formula. STDev, select all those. There we go, and click enter. There we go, the standard deviation again. Now I'm going to quickly do that for June. I'm going to show you why I've chosen to do it that way. So I'll just insert a row there, just to keep things orderly. I'm going to put June over here. Now I'm going to do the same thing for June. I'm going to show you why I went the copy and paste route. Equals June. Now I'm going to copy and paste these again. Could go the subtotal, remember. Oh. Control C, copy in there. So I've pasted them, and because the top row was hidden, I'm just going to move these back up again. Shift cell up, thank you. Now STDev, select the numbers in June. There's one less number for June because there's one less June measurement in all the recordings. So we go up, and there we go. We have the standard deviation of the mean maximum temperature for June since records began, which is just under a degree. So we've done this slightly clunky way of copying and pasting following a filter to get our values into a separate column. We've got them there. We've labelled them May and June so we don't forget what they are. So it's neat enough. And we've answered that question. Right, we've got the mean and we've got the standard deviation. Now let's go and make a histogram. We'll see it's important to have our numbers there because we can't do a subtotal for a histogram. We have to have the data in a separate column. So we do a histogram using our data analysis toolkit. Click on histogram, click OK. Now ask me for an input range. That's the numbers we want to do the histogram of. There we go. Bin range, it's asking me, do I want to select my own ranges for the x-axis of the histogram, or do I want Excel to do it for me? If I want Excel to do it for me, I can just leave it blank. And I'm feeling lazy, so I'm going to do that. Now it asks me, where do I want to put my histogram? I'm going to put it in a new worksheet, and click OK. Just give it a moment. Still thinking. Let's talk amongst yourselves. There we go at last. Now in a new worksheet, it's got our ranges known as the bins, and it's got the number which is in the middle of the range. See, if we were organising our ranges, our bins ourselves, we wouldn't make them as awkward as that. But Excel does it where it thinks it's best. Now it's automatically selected it ready to make a chart. So I'll just select them again. So after it's put that into that sheet, you can just straight away go to column, 2D column, and there it is. Thank you very much, Excel. There is our histogram with quite a nice spread, you have to admit, with the mean temperature around there, and that makes sense because it aligns with the mean maximum temperature. What's the mean maximum temperature? 16.7. So that'll be right at the base in here. And we can get Excel to put a trend line in for us. We go add trend line. We go moving average, close, and there's a little trend line for us as well, which has got a pretty much an even distribution. So that's how we do a histogram. We could do the same thing for June. I might as well do it. Hopefully it doesn't take so long this time. Go to data, data analysis toolpack, histogram. This time, just to mix it up, I'm going to select my own bins. There we go, I've selected all the data. Now I'm going to do my bins, and I'm going to do them in 0.5 increments, but I want to know what the lowest number to start my bins at and what the highest one is. So, whoops, and I'll just select those data points again. There we go. Actually, I'll just select my bins before we do that. So I want to put the ranges in for this histogram, but I want to start it at the minimum temperature and finish at the maximum temperature. I'm going to find out what that is by going equals min, selecting all the cells, press enter. So our minimum temperature is 11.6 and our max is have a look what our maximum is. 17.7. So now, just in a column here, I'm going to start it just below the minimum and work my way up in 0.5 increments to 18. And I'm going to use that as the bins for my histogram. So I go equals, want to select the data, here we go. Now we get to select our bins. There they are there. Thank you very much. New worksheet, yes. And there we go. So here are the bins I've nominated now and the frequencies of values found within them. And see how it's already highlighted. I can just go insert column, 2D column, and bang, there we go. So even with my bins, the histogram's still nice and even, just like before. I'll put in a trend line to prove that. And I'm going to argue that mine actually looks a little bit better. And look at that fantastic even distribution with this real outlier here at 18 degrees. I mean, that's a really hot June. Let's see when that was. I bet it was recently. No, it wasn't. Doesn't that make for good television? Me scrolling through. Oh, there it is, 17.7 then. So that was sometime in the 1950s. So that's how to do histograms, that's how to do the mean and standard deviation from large data sets, extract data which you can then graph.